Hey guys, this is writing formulas and naming ionic compounds that contain transition metals. So we just finished naming ionic compounds and writing their formulas, but now we're going to include transition metals. It's a little bit different. Alright, so these are the polyatomic ions that we'll be using. You need to know them. It makes life much easier than having to look back and forth to a piece of paper, so I suggest you get on that if you haven't done it already. And if you're still working on them, go ahead and pull it out and have it with you in front of you while you watch this video. And then I have a periodic table down here, and in the same way that I did last time, I'm going to color it in. So these elements down here right? Oh, crap. Okay. So you should have your periodic table look something like this using a colored pencil or something to help you remember what it looks like. Whenever you go to take a test, you'll have a visual memory of it because you're using it so much. Alright, so all of these that I shaded green, we don't know what their charge is. Everything else we do. And so if I wanted to know what anything in group 1 was, I would know that they're all +1, right? Except for hydrogen. Hydrogen can be +1 or -1. Okay, depending on how the ending is, right? Because hydrogen ion would be +1 and hydride would be -1. Aluminum is +3, carbon and silicone ± +4, nitrogen down to arsenic is -3, oxygen, sulfur, selenium -2, and then group 7 is -1. And then we have silver, which is always +1, zinc is always +2, and cadmium is always +2. So you need to know those. Alright, the ones here in the middle, right here, you need to know these because the periodic table is not going to tell you that. So unless you have their electron configurations memorized and you can understand why this happens, you just need to have them memorized. Alright, and then the transition metals here, their charges can vary. And I don't mean vary like this one would be +1 and this one would be +5. I mean they have more than one oxidation number. So like iron can be +2 or +3. Copper can be +1 or +2. And some of them have 5 or 6 different oxidation states that they exist as. So we're not going to memorize all those. There's no reason to memorize them all. We are going to learn a method to be able to tell what it is by what it's bonded to. Alright, so first, the way that we've been doing this, okay, is when we name compounds, we just name the cation and then we name the anion, right? This is the way we learned it in the last video or the last class or whatever. So this right here is magnesium, and this one is phosphate. So this would just simply be magnesium phosphate, right? And then when we write the formulas, we just write down the cation, and then we write down the anion, and then we balance the charges. We crisscross them down. So strontium is Sr, and it's 2+, looking at it from the periodic table. And nitride is N3- from the periodic table. And then we just take these charges and we bring them down. And that balances out the charges. Because if we have 3 SRs, oops, if we have 3 SRs, then we have 3 SR2+, and then we have 2 nitrogens. So that gives us 6 pluses and 6 negatives. So that cancels out, right? And so that's why there's no charge left on here. We have to do that for every ionic compound. All right, so that would be the right formula for strontium nitride. If you're having problems doing this still, you need to go back and watch the video that was uploaded before this one. All right. Okay, so knowing what we know, if we tried to name these two, we would simply just call this iron bromide, and this one would be iron bromide. But that's not correct because they have two different subscripts here. And that might not seem like much to you, but the difference between these two, this is water, and that's hydrogen peroxide. Okay, we drink this, we do not drink this. So one little number can make all the difference in the world. So we need to make sure that we can differentiate between these two compounds here by seeing their name, not just their formula. Okay, so what we need to do is look at the way the transition metals, or these metals that were not, the ones that were shaded in on the periodic table, we need to figure out a way to differentiate between the same element but different charge. And so if we look at, if we look at these, we've got copper like that, and so that's copper 1. We use Roman numerals for that. And then we have copper 2. And remember, metals are always going to get a plus oxidation, a positive oxidation number, or a positive charge, because they are not electronegative enough to take a negative charge. Okay, so these charges are also called oxidation numbers. All right, so oxidation. Sometimes they're referred to oxidation states. So the oxidation number for this copper is 1, plus 1, and the oxidation number for this one is plus 2 or 2 plus. And so all we do is we write the oxidation state in Roman numerals next to the element. Okay, so just in case you need it, 1, the Roman numeral is just a line, and 2 is 2 lines, 3 is 3 lines, all right, 5 is a V. Now if you want to subtract a number from the V, you put a line in front of it. So 4 would be a line, whoops, what was that? Would be a line and then a V. And 6 would be a V and then a line. So it really doesn't go higher than 7, or at least we won't here. I don't think it really goes over that anyways, for naming compounds, but there they are if you need them. So we put a 1 behind it to add to 5, and we put a 1 in front of it to subtract from 5. All right. So if we go back up to the top here where we had our iron compounds, right? We have iron bromide and iron bromide. And so for me to find out what the charge is, all I'm going to do is bring these charges back up. Because they were brought down, they were crisscrossed down to make the formula, so we should be able to bring them back up to find the name. So if I rewrite this, I would write Fe2 plus, Br minus, right? So I need to check to make sure my anion is correct. And I know that seems weird, but you'll see why here in a minute. Okay, so I check to make sure that bromine has the right charge on it. So if I look at my periodic table, bromine should have a -1 charge. So if this is correct, that means this charge is correct. And so we would name this iron 2 because it's got a 2+ charge. So remember, copper +1 has a 1+ charge, and so it's copper 1, right? So this is going to be iron 2 bromide. All right, you don't have to add anything extra to the anion. It's just going to be bromide because that is bromide. Okay, and then for this one, we're going to do the same thing. I'm going to bring this 3 up, bring this up. So I would get Fe3 plus, Br1 minus. And so since it now has a 3+ charge, right? First you got to check to make sure your anion is correct, and here it is. It's -1, so it's correct. So since it has a 3+ charge, it's going to be iron 3 bromide. All right, so now I'm going to do quite a few examples to help you understand. All right, so the first one we have here is MnCl2, and so since Mn is one of those elements in the shaded region on the periodic table, I have to bring my charges up. Okay, and when I do that, I get Mn2+ and Cl minus. And so next, I have to check the charge to make sure that it's right on the anion. So you need to check this one, make sure that it's correct, and chlorine should be -1, so that means that this is also correct. So that's going to be manganese to chloride. All right, so this is manganese, and that's 2, and then that's just chloride. Okay, so the next one, I've got Ti and then 2 CO3s, right? So I'm going to look at this, and since Ti is in the shaded region on the periodic table, the one that I colored in saying that it has more than one oxidation number, then we have to bring these up, right? We have to bring those back up so that we can figure out what to write as Roman numerals. So I've got Ti 2+ and CO3 1 minus. Next, you have to check your charges and make sure they're correct on the anion. So this is a polyatomic ion. It's on that separate sheet. This right here is not correct. Carbonate, CO3, should have a -2 charge, and it doesn't. So what I have to do is I have to multiply both of these by 2 to get this one back to -2. All right, and so if I do that, I end up with Ti4+ and CO3 2 minus. And so now this is correct, so that means that this one is correct too. So when I name this, it's going to be titanium for carbonate. Okay, and so what we're doing here is we're bringing up the ions. Okay, so we're bringing the subscripts back up. 2, we're checking the anion. And then 3, we're writing the name. Okay? All right, so let's see. Let's do a couple more. All right, so this one's a little tricky, okay? Most students are going to want to bring this 3 up here, and that is not correct. if you did this, now if you're taking notes, do not write this down. This is incorrect. If you did this and you brought that up, you would have Cu3NO minus. Now, if you look at the chart that I gave you, the polyatomic ions, the ions to know, this is not on there. It does not exist. Okay? So you don't need this. This can't be correct. You can't bring this up. You can't separate that 3. That changes this. This NO3 right here, is nitrate. Right? This NO3 right here is nitrate. So I can't just make that turn into something else. It wouldn't be correct. I have to keep it together. And so I'm going to go ahead and put parentheses around it. And then I can bring that up because I have 1 nitrate. So I can bring that number up. And then I have 1 copper, so I can bring that number up. So you have Cu plus and NO3 minus. Now I have to check my charge for nitrate. Right? And I've got, and that is correct for nitrate. It's -1. And so when I name this, it's going to be copper 1 nitrate. Okay? All right. So next we have Cu3PO42. So I'm going to bring up my charges. And I get Cu2 plus and PO4 3 minus. So next I have to check my charge on my anion. So is that correct for phosphate? Yes, it should be 3. And so I just have to name this. And so it's going to be copper 2 this time, phosphate. All right. Okay, I think this is the last one on here, and then I'll show you how to check your answers. So we have PbSO4, and so remember, this 4 right here is part of sulfate. I cannot move this 4 up here. See, this one, we had parentheses around it. We didn't move this 4. We moved the 2 outside of the parentheses. So if you have a polyatomic ion out here, put parentheses around it, and then you can move it up. Okay, so out here, right there, and so I get Pb plus SO4 minus. All right, and so now I have to check my charges to make sure they're correct. Is this correct for sulfate? No, it should be a -2. And so, since we need it to be -2, we have to multiply both of these by 2. So then I get lead 2 plus and SO4 2 minus. Now that this one is correct right here, that means that this one is correct too. So it's going to be lead 2, sulfate. Okay? All right. So I'm going to scroll back up here. Okay? And let's say we wanted to check these and we wanted to see if they were correct. All you would have to do, okay, is just look at the name. Don't look at what was up here. Look at the name and rewrite it as a formula, right? And so if I did that for manganese 2, I know manganese 2 is Mn2 plus. And chloride is Cl1 minus. And so if I wanted to write the formula, I'm just going to crisscross the charges down. And so I get MnCl2. And this is exactly what is up here. And so I know my name is right because I get the right formula from my name. Okay? So let's try this one, the next one. We have titanium 4 carbonate. And so titanium is Ti. And then 4 means you have a 4 plus charge. And then carbonate is CO3 2 minus. And so now I have to crisscross the charges down, right? Because we're not naming it. When we name it, we bring them up. When we're writing the formula, we bring them down. So when I do that, I get Ti2, and then parentheses, CO3, 4. Since I have a 2 and a 4, I can simplify that to TiCO3, 2. And that's exactly what we started with. Okay? All right, let's do one more. So right here I have copper 1 nitrate. And so for copper 1, it's just going to be Cu plus. And then nitrate is NO3 1 minus. And so I crisscross the 1's down and I get Cu NO3, which is the same thing that I started with. Okay, so you can always check your work with these, but it's not going to be checking your work very well if you can actually see these charges here. Okay, so make sure you cover them up or you don't look at them, and you should be good to go. All right, so we're just going to write a few of the compounds real quick, the formulas from the compounds. So we just have to write down the ions and crisscross them down. So lead 2 is Pb2 plus, and nitrite is NO2 1 minus. So crisscross, and I get Pb, and remember nitrite has to be in parentheses because we need 2 of all of this, not just 2 of oxygen or 2 of nitrogen. We need 2 of the whole thing. All right, and then next we have gold 3 chloride, and so gold 3 is Au3 plus, and then chloride is Cl minus, right? So we're going to crisscross these charges down, and when I do that, I get AuCl3. All right, and then vanadium 3 sulfide. So vanadium 3 is V3. Sulfide is S2 negative. So when we crisscross these down, we end up with V2 S3. Whoa, that didn't move. All right, and then next we have cobalt 4 sulfite. So cobalt 4 is CO4 plus. Sulfite is SO3 3 minus. Oh, I'm sorry, that's SO2. One minus. And so I'm going to cross these charges down. And when I do that, I get CO4. Oh, what am I doing? Not paying attention. CO2, SO3, 4. So I have a 2 and a 4, and that can be simplified. And so what I end up getting, this becomes a 1, and that becomes a 2. So I have CO, SO3, 2. All right, last one. We've got iron 3 phosphate. So iron 3 is Fe3 plus, and phosphate is PO4 3 minus. So I'm going to crisscross these down, and I end up with Fe PO4 because the 3's cancel out. Okay, so on the next slide I have a summary of what to do in each situation. If you want to, you can pause it and write it down, take a screenshot, whatever you want to do, so that it can help you. I'm not going to leave it up for very long, so if you want it, it's there. So, naming ionic compounds. First, if the element only has one oxidation number, just name the cation, then the anion. And so that's something like magnesium chloride. right? You just have to name it, because we know that magnesium is +2. There's no question about it. All right, or silver bromide. Silver is always +1. There's no reason to state that this is silver 1 bromide. We know that it's +1. Okay? If the element has more than one oxidation number, bring the charges back up and make sure the anion is correct. Make it right if needed. Then name the cation, then the anion. All right? So this right here is the new stuff. And this is the old. So this is what we learned today, and this is what we learned the day before. All right, in writing formulas, we do it both the same way. The only difference is in the names, with the ones with the transition metals, you have the charge given to you. You don't have to look at the periodic table for it. All right, guys. So good luck. If you have questions, make sure you ask questions. Keep watching the video. Work as many examples and problems as you possibly can.